Hey everybody! Today we are going to use arrays to solve decimal multiplication problems. So before we do this, I want to think a little bit about the powers of 10. So the powers of 10 means multiplying by 10. So it's like 10, 100, 1000, 10,000, 1000. And in this video, we're going to see what the world looks like from 10 meters off the ground, 100 meters, 1,000 meters, 10,000, and 100,000. So each time it's zooming out 10 times more.
The picnic near the lakeside in Chicago is the start of a lazy afternoon, early 1 October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now, every 10 seconds, we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds, the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide, the distance a man can run in 10 seconds. Cars crowd the highway, power boats lie at their docks. The colorful bleachers are Soldiers Field. This square is 1 kilometer wide, 1,000 meters. The distance a racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake. 10 to the 5th meters, the distance an orbiting satellite covers in 10 seconds. Long parades of clouds, the day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros.
So this is 1 million meters.
Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move.
So what happened is we multiplied it by 10 7 times and then 8 times. So each time we were multiplying it by 10 and it was getting 10 times bigger. So you can see that things rapidly grow bigger or smaller when you keep multiplying them by 10. Or if you keep dividing them by 10, they get smaller. So let's say that we're buying holiday cards. Maybe we're sending them to one friend, maybe we're sending them to the whole school. So one card would cost $3, 10 cards would cost $30, 100 cards would cost $300, and 1,000 cards would cost $3,000. So what patterns do you notice? How is the cost of the cards getting bigger? Let's look at another example. Let's say we need a stamp to go on our holiday cards. Now, if this stamp costs 3 cents, 10 stamps would cost 30 cents, 100 stamps would cost $3, and 1,000 stamps would cost $30. So what do you notice now? How are those numbers getting bigger? So let's look at that pattern. So 3 cents times 1 has 3 hundredths. 3 cents times 10 has 3 tenths. So it's 10 times as much. If we multiply it by 100, it's again 10 times as much. So 3 tenths 10 times is 10 ones. And let's say we multiply it by 10 again. 3 ones times 10 is 3 tens, or 30. And I'm sure you guys already know that from your multiplication facts that 3 times 10 is 30. So again, we're seeing a pattern. In this pattern, you could think about it as the decimal point staying in the same place and the 3 moving every time you multiply it by 10. So let's look at another example. This stamp costs 25 cents. If I buy one 25-cent stamp, it costs me 25 cents. The decimal point is right here to show that there's no holes and these are cents. If I buy 10 of these stamps, the decimal point will move over. And now I'm paying $2.50. So you can notice that this time we're looking at it differently. And rather than seeing the numbers move, you're seeing the decimal point move. The same thing is happening, it's just another way to see it. So let's say now we have 25-cent stamps and we buy 100 of them. Our decimal point moved 2 times. And now it costs $25. Now let's say we buy 1,000. Our decimal point has to move 3 times. Now it costs $250. So what's the pattern that's happening here? What do we notice? When there is 1 0, the decimal point moved 1 time. When there were 2 zeros, the decimal point moved 2 times. When there were 3 zeros in the number we were multiplying, the decimal point moved 3 times. So the number of zeros is the number of jumps in this number. So 10 has 1 0, the decimal point moves 1 time. So whenever you're trying to figure out how many jumps to move the decimal point, you can look at the zeros in 10, 100, or 1,000. So for homework, you're going to complete this table. And it's okay if you want to use a calculator to help you, just to get the hang of where the decimal point goes for this one. So we're starting with 5 cents times 1. So obviously we have 0 tens, 0 ones, 0 tenths, and 5 hundredths. Because when we multiply something by 1, it stays the same. Then when we have 5 cents times 10, I could use my picture if I want. I know that's 50 cents. Because 5 cents times 10 would be 50. So it's 5 tenths, 0 hundredths, still 0 ones, still 0 tens. So that's what you'll do on the first one. And then on this one, we're going to move the decimal point. So let's say we do 1 times 0.67. I'll put this decimal point right here to show where it should go in the number. And you're going to do that for each of these. Remember to use your trick with the zeros. So if the decimal point started here in 0.67 and I multiply by 10, it's going to jump over 1 to show me the number 6.7, or 6 7/10. And lastly, you're going to have a word problem. I did the first one as an example. You can do the second one and the third one, and make sure you tell us how you know. All right, let's start.